All right, is the audio working this time? Tell me if the technology is happening. It is not to be trusted. Live. All right. Excellent. No sound. Okay. Careful, Guillaume. That would just send me for 5 minutes of technology scramble. Is that what you want? Is that what you want? Um. All right. Let me just get everything ready here. All right. So, hey everyone, welcome to the question show. Your questions, my answers. Um, so before I get into this week's show, did you see the new release that came out today? You've been asking about the TRAPPIST-1 system, and we finally got some information about the TRAPPIST-1 system, and they're killing me. So they released information on one planet, on the first, so TRAPPIST-1b, which is a planet that's like bigger than the Earth, but orbits so close that it's extremely hot. It's well within the habitable zone, so it's definitely not habitable. The temperatures are roughly in between Mercury and Earth, and they were able to measure the temperature of the planet, able to determine that it doesn't have an atmosphere, so it sucks. But even though they've done data on all of the TRAPPIST planets, they just released the one. So is this how this is going to work? Is they're just going to release one, and then in a few months they'll release another one, and this is killing me. Just want to know what's happening on the TRAPPIST-1 system. So anyway, that was a thing. All right. So, for those of you who are wondering what it is you have stumbled into, this is going to be a live episode of the question show, the Your Questions, My Answers part. We will go through some initial questions that I've pulled from over the last week, and then we'll go into your questions. So go ahead and put any questions that you might have about space and/or astronomy in the chat, and we will try to get at them as many as possible. We will go until the end of the hour, and then I will wrap up the recording, but we'll stick around and do overtime. So for however long I have energy to keep going. So before I just get so hungry and just need to go. So go ahead, like I said, put in your questions. Now, if I don't answer your question, there's a couple of reasons. One is I try to put emphasis on the people who've never had a question answered before, and I can definitely see who has had their questions make it into the question show and who hasn't. So if that's you, I apologize. I just want to try and share the opportunity to as many people as possible. The other thing is that I might not know the answer. Like you might be asking a question that would be better asked to Kip Thorne or Sean Carroll or some theoretical cosmologist. I'm just a journalist. I only know what the scientists tell me. And then the other thing is if it requires like too much calculation, I don't know if we have time to have me do math, go over to Wolfram Alpha, start adding things up. So just keep that in mind. And also if it's like a question that we handled a lot recently, then there you go. All right, so let's get going. Yeah, David Kipping, there you go. He'll answer your questions. Or will he? Okay. Let us begin. Oh, I'm going to start my audio. Okay. And that's working. All right, here we go. Oh, and I click on that. All right. Hi, everyone. Welcome to the question show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. We also record the show live every Monday at 5 p.m. Pacific. So if you want to come and join the show live, you can carry on the conversation with other people, ask follow-on questions. It's a lot of fun. It's about double the length of this edited down version that you're watching here today. And there should be an event here somewhere on the channel. You can click to, I guess, get a notification when the live events are happening, and then you can come and join us. All right, let's get into the questions. Jason, question. What is the theoretical size of a planet? I've heard that planets will start to shrink if they get too massive. So what is the limit in size before they start to turn into a star? This is kind of cool. The largest possible planet is about the size of Jupiter. So Jupiter is about 11 times the size of Earth. Like if you put 11 Earths side by side, that is the size of Jupiter. And Jupiter is sort of at the theoretical limit of how big a planet can be. And that if you add more mass to Jupiter, it will actually start to make the planet compress down in on itself, smaller and smaller and smaller. Now, there's a limit, of course, but still, more massive planets don't get a lot bigger than Jupiter. So just to give you another example, like if you were to add 13 times the mass of Jupiter to it, then it would become a brown dwarf. And again, it wouldn't be any bigger than Jupiter, but now it would have such a dense core that it's starting to fuse deuterium. It would start to be generating heat inside its core because of this fusion process, and it would still remain roughly Jupiter-sized. In fact, the TRAPPIST-1a star, this is the one famously that has like 7 Earth-like worlds orbiting around it, it is a red dwarf star, but it's only about 10% bigger than Jupiter. And so Jupiter is the same size as a star that has close to 100 times the mass that Jupiter does. And that just shows you that when it comes to planets, really Jupiter is at the very limit of how big a planet will become. And there are even red dwarfs that are smaller than Jupiter. So it'd be very strange, right? Can you imagine you would have like a Jupiter mass planet orbiting around a red dwarf star, and the planet is bigger than the star, even though the star is going to have 100 times more mass than the planet. All right. Oh, I see the problem. Okay. Apologies. Okay. Now, I'm sure you've noticed this exoplanet name from the Star Wars universe pop up over my shoulder, and that is a way for you to vote on the questions that you thought were the best this week. And this week's one was a landslide, and that was for Can't Be Serious about whether humanity will have a powerful enough telescope to see an Earth-sized planet orbiting a sun-like star in the habitable zone. I feel like I guess I gave a good answer, but I know it's a very sad answer, which is that the answer is no, we don't. But if you haven't already watched that episode, we'll put a link in the show notes. You should definitely go and check that out. But again, if you're watching this episode, count. So with today's episode, watch through all of the questions, pick the one that you like the best, and vote down in the comments. Just type in the name of the Star Wars planet that you like the best. We'll count up all the votes, and we will celebrate it next week. Fugel. How complex do the spacecraft need to be at 1000 AU to make use of the solar gravitational lens? We talked about this last week, that the way that we're going to be able to directly image an Earth-sized world orbiting around a sun-like star with the kind of resolution that makes us really feel like we're living in that science fiction future is with the solar gravitational lens. And this is where you fly a spacecraft out to about 1,000 astronomical units. And at this point, the gravity from the sun acts like a natural telescope lens. But 1,000 astronomical units is very, very far away. When you think about the Voyager spacecraft, they were launched back in the 1970s, and they've not even crossed 200 astronomical units. Let me get the exact distance. I think that's right. 150, 160. Wolfram Alpha, Voyager 2, Voyager 1? Which one's farther? Voyager 1. distance. Okay. 159. Nice. Okay. When you think about the Voyager spacecraft, Voyager 1, which is the most distant object ever sent by humanity, is at 159 astronomical units, and it's been flying since 1977. So if you want to be able to make that journey within a human lifetime, we're going to need methods of flying a lot faster. And we've talked a ton about this here on the channel. There's a lot of NIAC awards. There are various solar sails, mag sails. There are these strange pellet guns that will be able to fire material at spacecraft to accelerate them. You're looking at nuclear rockets, fusion rockets. There's a lot of great ideas to try and really dramatically decrease the flight time to get out to the solar gravitational lens. But still, it's going to be expensive. You're going to need a fairly large rocket with a very powerful way of getting out that far away from the solar system if you want to be able to do it in any reasonable amount of time. And so you have to pick your target really, really carefully. You know, we talked about this as well, that we're going to have to be absolutely certain which individual exoplanet we want to send a spacecraft out to be able to image. The size of the telescope actually isn't that big. You could have a telescope be about 1 meter across, which, 3 feet. So dramatically smaller than the Hubble Space Telescope. And even one that is smaller than that would still do a really good job. And so I think you're exactly on the right path here, which is that, we always talk about how TESS is the finder scope for the James Webb Space Telescope. Well, the James Webb Space Telescope is the finder scope for the Solar Gravitational Lens Telescopes, many of them. And so as various exoplanets finally meet a certain criteria for characteristics in their atmosphere, changes in their albedo as the planet seems to be orbiting, other trace detections that we can make, we will spin up these solar gravitational lens telescopes and start throwing them out to the solar gravitational lenses all the way across the solar system. Maybe you'll send multiple ones in one spacecraft so that they can work together to move to their various final positions if the targets are clustered in the same area. And so I wouldn't be surprised. Like, there will be a time when we will send one, and then a few years after that we'll send a couple more, and then after that we'll send a few more, and it'll still be like 20 years before the first ones start to arrive into this observation cone where they can start to actually see their targets. And over time we will have discovered more and more and more, and each time we find a really compelling new exoplanet, we will send another one on its way, and then we just have to be patient. But then as spacecraft get faster, as our propulsion systems get faster, we can get this weird situation where the most recent solar gravitational lens telescope arrives before the first one was sent. And so it's kind of like the weight calculation. We're going to have these telescopes arriving at different times as our technology improves and as we get sort of are able to see more and more of the universe. So it feels like that is the future, that having these solar gravitational lens telescopes, the ones that give us that megapixel image, 1,000 pixels by 1,000 pixels, like that is such a compelling vision for what the future of exoplanetary astronomy looks like, that it feels inevitable, that it's just a matter of time but as we work out the various technology and finally choose that target that we're going to send it to. Now, I've got a very long conversation about this technology with Dr. Slava Turishev. He's the guy who developed the concept, received NIAC grants to be able to work on it, and we talk about this at length and hopefully answer most of your questions about this idea of the solar gravitational lens. So we'll put a link to that in the show notes as well. I look small tonight and off center. Yeah, my setup is totally messed. What you can't see is that a pipe broke here in my office, and we have been dismantling and putting together the office every couple of days for me to be able to keep doing work. And then the workers come in and cover everything in tarps and sand, and we're moving furniture around. So the fact that I'm even in here is a wonder. And we're at the point now where first paint is on the wall, but all the trim has been removed off all of the walls, and so hopefully we'll get there. And then finally, and also one of my lights is busted. And this, anyway, it's still a shakeout cruise to get this thing working. All right. Oh, actually, when does Psyche flying? Okay. Sorry. Yeah, the pipe froze, and the builder was like, "Uh-oh, did you not like? Did you have hoses and stuff connected to the pipe?" And we did. Um, so I was like, "Oh no, this is gonna be on me." And then they opened up the wall, and it turns out that there hadn't been adequate insulation, and the temperature got down to like -15 outside, and the hose bib broke, and so it had been leaking in the walls, and there's like water coming out of the electrical sockets, which that can't be good. So anyway, it's been a thing. All right, baby Makar. On the topic of mining asteroids, how would you mine solid metal asteroids like Psyche, or would you just build a giant furnace and melt it down in one big chunk? I'm sure you've seen so many of these articles on the internet about NASA is planning to send a mission to an asteroid that's worth, and then they just come up with some enormous number, right? Like it's 70 quadrillion dollars. It would make everyone on Earth a multi-trillionaire, et cetera, et cetera. And that is, I guess, true. But then if you like brought that much metal, precious metal, back to Earth, and it would devalue all the metal and it would crash the world economy. And so it's not really that accurate. But the question you're asking is like, how would you get this stuff? Like if asteroid Psyche is just a ball of solid metal, how do you asteroid mine a ball of metal? And the answer is that it's probably not a ball of metal. It's a mixture of metal and rock and other stuff. And so we got some new images from asteroid Psyche within the last couple of years. And this helped sort of give a better sense of what the surface is like. And it's probably more mixed. So instead of just being this gleaming planetoid of chrome, it's think about something that is more would look much more like many of the other asteroids that are here in the solar system, and it's going to have craters and pockmarks and all that across it. It's going to have lots of debris and rock on its surface, but it also clearly has the density to see that it still has a lot of metal, and maybe it even has like metal volcanoes or the remnants of metal volcanoes. So how would you mine it? I mean, the same way that you would mine any asteroid. You would land on the surface, you would set up your railgun on the surface, you would start to grab chunks that are just sitting there on the surface, plop them in your railgun, fire them off into space. Maybe you have two railguns going that are counteracting each other so that they don't cause the asteroid to start spinning too quickly from the reaction of firing this material into space. And eventually, you would have cleaned off the surface of the material. Eventually, you would have cleaned off the surface of the asteroid for anything that was easy to pick up. And then you are indeed left with metal. How do you extract metal? I mean, when you're really far away from the sun, like there are ways that you can concentrate the power of the sun. You can set up some kind of smelter to try and remove it, but it sounds hard. So probably they'll stop. Oh, it's a good question, Megavoltmeister. And we'll get to that. Okay. Next up. All right, so those were all of the prepared questions. So now let's get into the live questions. Maybe catch another reminder to the list. Praise you to turn off the hose bibs for the winter. Yeah, we'll have a button here that says remove the hose bibs for the winter. TRAPPIST probe when? Good question. Tim G, why is it called TRAPPIST, by the way? So the TRAPPIST, sort of two parts to this telescope. So it's a Belgian robotic telescope, and it stands for Transiting Planets and Planetesimals Small Telescope. And but Trappist is also the name of a monastery order in Belgium that makes beer. It's very famous for making beer. You can get a Trappist beer. And so obviously it's a backronym. They thought of a clever acronym that they wanted to use that had meaning in Belgium, and then figured out all the different words that go with it. So it's pretty great. I like it. Although the question's like how many Trappists? I mean, there's Trappist one. How many other discoveries have they made? Is that it? Just it? Like, have they found any other planets? Because there's Trappist North and Trappist South. Yeah, it's weird. Not beer ale. Oh, sorry. Oh, there you go. 8. 8 so far. That's cool. Okay. Because you don't hear about them. Random one. So isn't this the week we should be able to see a couple of planets at dusk? Yeah, well, I mean, you could see planets at dusk every day, but the planets are going to be lined up in this really nice way with the moon this week. But like, if you look to the west, Venus is so bright, and so is Jupiter. And I think you can see Mercury, Venus, Jupiter, Saturn, Mars all together, as well as the moon. Just in case you had trouble finding them. Tornak is in question. What's the best planetarium in Asia? Well, I'm assuming it's in China. Like, have you seen pictures of the planetarium or the space museum in Shanghai? Looks pretty amazing. So I would assume, like, they're adding a new museum every 3 days in China. Jim 22 150 is the theoretical planet size universe wide? Yeah, like it's just like the laws of physics demand it. Sorry, I'm just looking through the questions. NorCal Pacific. I just read Sabina Hassenfelder's book, Lost in Math. Do you agree that string theory is hogwash and a waste of 40 years of physics? Likewise, no Susie particles. So I'm not a physicist, so I'm going to have to take Sabina's position on this over, I have interviewed people, and actually it was an interview that I did about a year ago with the creator from the Not Even Wrong. I think that's his blog. And he has sort of a very similar perspective that string theory has sort of gobbled up great minds for the better part of a year, or better part of 30 years. And so we go into that. So, like, just in general, like, I'm not a physicist. I'm merely a journalist. And NorCal Pacific, we ever interview Sabina Hasselfelder about how lost in physics? Yeah, I've already interviewed about that a couple of times. So if you do a search for Fraser, Cain, Sabina Hassenfelder, I think it was on the Weekly Space Hangout where, Peter White. There you go. Yeah, T-Home. Yeah, thanks. Peter White. So I interviewed him about it and sort of covered the same ground. And I also interviewed Sabina about lost in math. Although I didn't do a great job. I wasn't that knowledgeable back then when I did it. So, Megavolt Meister, how do we detect magnetic fields outside of our solar system? Yeah, you've probably heard a lot of research where astronomers say we see magnetic field lines out there in the universe. And like, it's not like you're getting a magnet close to a giant galaxy cluster. How do you detect those magnetic field lines? And it comes through the particles. They're following along these magnetic field lines. As the particles are whipping around these galaxies, as they're whipping around star systems, as they are going around black holes, neutron stars, magnetars, they emit radiation. And so astronomers are able to detect the radiation that's coming from these particles and then use that to map back to actually figure out the strength of the magnetic field in various places that they're looking. One really cool idea is that astronomers soon will be able to detect exoplanets because of the magnetic field lines around these planets. When we think about the Earth, right? We are surrounded by a magnetosphere, and that protects us from the Earth. And as particles from the sun are streaming towards the Earth and they impact the Earth's magnetosphere, we get auroras. And from some distant observer, they're going to see the radiation that is coming off of Earth because of the interaction between the magnetosphere and the particles that are hitting the Earth. And so when you think about it, right, they are detecting the radiation, the auroras that are coming from the planet, and using that to infer that planet Earth has a magnetic field. And we'll be able to do the same thing. We'll be able to look at other planetary systems, detect that telltale signature of an aurora on a planet, and detect the existence of the planet at the same time that we also know that that planet is protected by a magnetosphere. And these, it's just within our limits right now, but there are other telescopes coming that will be able to do that. This idea of putting a radio telescope on the far side of the moon, one that can see the longest wavelengths, that's the kind of target that we'll be able to pick up, as well as being able to peer into the dark ages of the universe and measure the magnetic field lines around. So mainly this work is done in the radio wave spectrum. Where are we at? Okay. A.B. Scott and Flower, what? A new planet announced around Alpha Centauri? What? Is there a planet announced around Alpha Centauri? I don't think so. But we talked about the Ptolemy telescope that's going to be able to image planets around Alpha Centauri. It launches in 2024, and it should give us an answer within about a year or 2 years after it launches. So that's when we'll know if there's planets at Alpha Centauri. But it's not long. Breakthrough Foundation is funding the launch of this telescope. It's going to be a very small, humble telescope, just a CubeSat. It's going to be able to fit within an existing launch. I'm really excited for this idea. Jen just finished my astrophysics degree. Congratulations, Jen. What, a doctorate? Or so? What was your final thesis? What was your final paper about? I'm guessing astrophysics. That's awesome. We used to joke that we help people get their doctorates on the weekly Space Hangout. So clearly we're just continuing on this tradition of helping people get their, oh, there you go, in their undergraduate degree. All right. So are you going to move on to go get your master's and your PhD? Kinetic Dyslexic. Do we know which space telescopes China has funded? I know one or two of the larger ones being built, they're funding. There are a lot of projects that are coming out of China, and I kind of struggle to keep track of all of the projects. I mean, they've got the largest radio telescope on Earth. They're building the largest steerable radio telescope on Earth. The one mission that I know a lot about is that they're planning on building their own space telescope, their version of the Hubble Space Telescope. Let me just get the name. Get this. Get the. What's it going to be called? Xintian. The Chinese Survey Space Telescope. Okay. So the telescope's called Xintian, and it's going to be a 2-meter telescope. When you think about Hubble, it's 2.4 meters, so it's going to be a little smaller than the Hubble Space Telescope. And the original plan for Xintian was that they were going to take this telescope and attach it to their space station. And so there would be some disadvantage to that, like it would be experiencing all of the vibrations on the space station, but then you would have all the advantages, like you could do spacewalks, repair it, swap out new gear, etc. And I guess later on they decided that wasn't the best idea, but it's going to fly in formation with their space station, and then it's going to dock to the space station whenever they need to make various upgrades. So I think it's a very clever idea. The other thing is that it's going to have a much wider field of view than the Hubble Space Telescope. It's going to be more similar to like the Nancy Grace Roman, which is also a Hubble class telescope. And it's going to be able to have this very wide field of view and help assist in the search for dark matter, dark energy, you know, the large scale structure of the universe to help figure out the evolution of the universe. But there've been a lot of other missions that China has proposed and has in the works, and they've really specialized in the radio spectrum. As I said, they've got all of the biggest radio telescopes in the world that they're working on, and I think they're working on a radio, I don't want to, space radio telescope. Man, like it all just blurs for me. Nope. Okay. Space telescopes. Let me just get the list. Yeah, all right. I'll keep this. All right. I've seen a ton of papers where Chinese space scientists are proposing different ideas for space telescopes. We've reported on a bunch of them at Universe Today. So the Xintian is the big one that is in the works, but you know, depending on how many of these actually see space, there could be a lot of them in the future. Gamma Program Kid 56. Hey, I wonder, do you think they will ever discover the rest of the universe in the far future? We know that, again, when we look out into the universe, we are seeing all of the regions where light has been traveling from essentially the beginning of the universe to reach us. We call that the observable universe. And wherever you stand, you are at the center of your own observable universe. So you're watching this video and you're halfway across the earth from me, or maybe you're in the same country, I don't know. But you have your observable universe, the sphere that is centered on you, that you can look in any one direction, about 46 billion light years, and you're seeing the beginning of the universe, because that's how long it's taken for that light to go from the Big Bang to you today. I have a different observable universe. We all have our own observable universe. And the way I like to sort of think about it is if you're like wandering around in a very thick fog, right? That you can see your hands in front of you, you can see stuff around you, but after a while the fog gets very thick and you can't see far away. And yet I can be in my part of the fog, you're in your part of the fog. We're all seeing our own separate observable universes in the fog. And so when you think about it, like just objectively, there is more universe outside of my observable universe. There's more universe outside of your observable universe. And from what astronomers can tell, the actual universe is at least 1,000 times bigger than the observable universe that we can see. And the other possibility is that it's infinite. Like, astronomers don't know if it's merely 1,000 times bigger than what we can see or it's infinite. The point is that we can't tell because essentially the flatness of the universe is so perfect that it rules out anything that is smaller than about 1,000 times in volume than what we can see with the observable universe. And so the question you're asking is, can we ever know if there's, or I guess the question that you're asking is like, can we ever know anything about the rest of that universe? And we could do better and better observations at the curvature of the universe, and we could push that minimum size up. So we might like really precisely measure the flatness of the universe and get to a point where we say, okay, the universe is at least 10,000 times bigger than we know, or 100,000 times bigger than we know. But we can never visit it. We can never go beyond the observable universe. In fact, we can't even get to the observable universe that we can see. 96% of the universe is already moving away from us at the speed of light or faster. And so even if we left today at the speed of light, we could only reach a sphere around us that accounts for about 4% of the observable universe. And so not only can we not find out what's going on outside of the universe that we can observe, we can't even reach the universe that we can observe, which is kind of sad. But it's just that's what you get when things are just gigantic, possibly infinite. Jen, who's your favorite astronomer, alive or dead? Probably Galileo. Although, I mean, I like Galileo because he was like the first person to point a telescope at the sky and that we know of, and took very detailed notes of what he did, drew what he was seeing. So he was both a really good scientist, but also was just fortunate enough that the most important scientific tool for astronomers fell into his hands at the right time. So he was like the right guy at the right place. But at the same time, he had a lot of questions and tried to get the answers that he could, but he also pissed off a lot of people and got himself in trouble. I mean, he wasn't burned at the stake, but he definitely made a lot of enemies. And and I think partly it was like his personality. Like he made more enemies than he had to, partly just because of the way he behaved. And I think it's kind of interesting. He just pushed back against authority. Yeah, I find Galileo really fascinating. So I think, if there's like one, I always talk about this, like one astronomer that I could talk to, I think it would be Galileo. Frogs, we're only getting to the point that we could accurately simulate reality. What are the chances it's already happened? I'm just an NPC in a simulation. Am I player one? Are you? Um, well, you think therefore you are, right? I think therefore I am, which is a pretty, like, just the fact that you are perceiving the world around you means that you know that for sure at least you exist. And that's like better than nothing. Do we all exist? Are you in a simulation and I'm just part of the simulation that you're imagining? Not from my perspective. I know that I exist, and I'm not sure that you're that you're just being part of my simulation. Um, we can never know. We will never know, and so we have to behave as if this reality is all we get and make the most of it. So don't for a second, like, you know, be lulled into a false sense of simulated security. Assume that this is all you get, and we want to have the best time that we can, make the biggest impact, improve the lives of other people now and into the future. and live a life that you find meaningful. And that was one of the 4 options that I had in my NPC tree. Steve Woolbrand. Oumuamua, artificial or natural? I don't know. But like most likely it's natural. I mean, when you think about all of the possibilities out there, Occam's razor tells you that it's just got to be a rock or a rock with ice on it. And I know that Avi Loeb will disagree with me, and he is a Harvard astrophysicist who knows a ton, and so I'm, obviously I'm not gonna have a straight up argument with him, but I just sort of like my experience in watching as interesting new discoveries eventually become more and more mundane when people finally figured out what it is that they are. The most recent idea is that Oumuamua is probably like the thought is that it was formed far out in whatever solar system that it came from, and it was able to escape into the universe, and then it was bombarded with hydrogen atoms over the millions or billions of years as it was floating through space, and all of this hydrogen kind of compacted onto the outside of the object as it made its way through space, this hydrogen iceberg. And then as it approached the solar system for the first time, this material started to outgas in an unbalanced way. So instead of it sort of outgassing in all directions, it outgassed in a way that changed its acceleration in surprising ways. And according to recent calculations, this is within the possibilities of what hydrogen outgassing could do. So like hydrogen outgassing seems like a more feasible answer to me than it's aliens. And don't get me wrong, right? Like I never shut up about von Neumann probes that are traveling from star system to star system. And I would love for it to be some kind of alien probe that's sent to the solar system to learn more about us and maybe to share its technology. Although now it's leaving us, like it's not sticking around, which is kind of rude. So no, I feel when you look at all of the interesting things that have been found, Boyajian star, was it some kind of Dyson sphere surrounding a star? Nope, just dust. So it just feels almost certain that this will turn out to be something that's completely natural. That when we do find some kind of result of intelligence, it's going to be very obvious, and it will be, there will be a lot of argument about what it is. Planet to be caught in Lagrange points of a binary star system and stars rotating around the planet. What? Planet caught in the Lagrange point of a binary star system. Okay. Donovan Smith. Is it possible for a planet to be caught in the Lagrange point of a binary star system and so have the stars rotating around the planet? All right, I had to read this question a couple of times to sort of wrap my head around what's going on here. So you've got a binary star system. You've got 2 stars that are orbiting around a common center of gravity in between them. And so both stars are rotating this empty spot in space. And then you're asking, could you put a planet at the middle of this empty spot in space and then have the 2 stars orbiting around it? And it would feel like you are at the center of the star system. And so the like heliocentric model of the star system would be wrong. It would be the Earth centric or the planet centric. And that sounds really cool and really exciting. It sounds like a really cool science fiction story, but no. And the problem is that position would be unstable. And so back to the Lagrange points, right? When you think about, there are 5 Lagrange points around every 2 objects with vastly different amounts of mass. So if you have a object with the mass of the sun and you have an object with the mass of planet Earth, then there are 5 Lagrange points. 3 of them are lined up between the star and the planet, and they are unstable. They are like sitting a rock at the top of a tall mountain, and any kick pushes the planet off of the rock off the top of this mountain, it's going to roll down faster and faster and move away. And so when you think about all the spacecraft that we have positioned at the different Lagrange points, say James Webb, which is at the L2 point, it has to use propellant nonstop to maintain that position. And as soon as it stops using its propellant, it'll start to drift away from the Lagrange point. Well, you would have this same situation. You've got these 2 stars and they're orbiting around each other, and they're not going to be exactly the same kind of mass. And so this balance point in between them is going to shift and move around, and the planet isn't going to be able to stay in that shifting, moving plane. So it's going to drift out, and eventually it's going to hit one of the stars. But you could have planets orbiting around binary star systems, but they have to be orbiting there's 2 scenarios where this is possible. One is you got the 2 stars that are relatively close together, say a couple of astronomical units away from each other, and then you have your planet orbiting both stars, and it has to be like a factor of 5 beyond the distance between the 2 stars together, and then you can have the whole thing be stable, and the planet will just orbit around these 2 stars, which would still be pretty great. I mean, you'd look and you'd see the stars would be sort of in the sky. Sometimes they would be lined up, and sometimes they'd be far apart, and they would just be kind of doing this. The other possibility is that if the stars are really far apart, then your planet can orbit one of the stars and not be completely disturbed by the other star. And so then I guess the question that you're asking as well is like, could you get Lagrange points from a binary star system? And the answer would be yes. So if you had your 2 stars orbiting one another in this binary system, and then you had a large planet far away from them, say a Jupiter or whatever, to the point that it was stable, then you would end up with those same 5 Lagrange points. One that is in between the binary stars and your Jupiter, one that's on the other side of your Jupiter, one that's on the other side of the 2 stars, as well as the 2 that are forward and backwards in the orbit of the planet. But because these 2 stars are whirling around each other, the shape of these Lagrange points are going to change dynamically depending on how the stars are lining themselves up. And so you might end up with either a very large point that isn't like a pinpoint gravitational balance, but is this sort of gravitational blob where you can kind of stay in the region. And same thing with, say, the L4 and the L5. They're gravitationally stable. They're like the opposite. They're like a valley that you can get into and you sort of hang around inside of there. But then I wonder, right, if you had the 2 stars orbiting around each other, depending on how far away they are apart from each other, how away from your planet is, they might actually cause those Lagrange points to be unstable again. So it's an interesting question. It's not a Lagrange point question that I've had before. So I'll just add that to the list. A kinetic distance, 3 stars orbiting each other. Actually, the most that's known is 7 stars orbiting around stably around each other. And so you have to have these combinations. You can either have 2 stars orbiting each other and then like 2 stars orbiting each other. So you've got 4, and then they're orbiting a common center. And so now you've got it to be stable. And then you could have 2 more orbiting those others, and then 1 more star orbiting all of them. So as long as you are able to sort of build them up in these pairs stably or have them be far away, then you can just run the numbers up. I'm sure out there somewhere in the universe there's something that's beyond 7. Maybe somewhere there's a planetary system or a star system with 10 stars orbiting stably around each other. That is so cool that all of the combinations, like wouldn't you love to know the answer of like what is the most stars in a system in the entire universe? Wouldn't that be cool to know the answer? And yet we will never know because we're stuck in this one corner of the Milky Way and we can only see what we can see. kind of propellant does James Webb use? I think he uses hydrazine. Eight monopropellant rocket engines. So it's got monopropellant. Let's see. James Webb. Now. MRE ones. Yeah, hydrazine. Yeah, okay. All right. Uses hydrazine. Prismlaw Legion. Sure. Prismlaw Legion. What is your take on artificial versus organic intelligence? I don't think there's anything special about organic intelligence. Like, we are the result of hundreds of millions of years of evolution here on Earth, evolution through natural selection. And natural selection sort of made the brain, and this is how we got our intelligence. But it wasn't the plan. It was just that our ancestors were able to survive in their environments better, and everyone of all of everyone who's watching this, right? All of our ancestors survived long enough to be able to produce offspring, and we are the result of that. And so there are all kinds of ways the human brain has got problems, and there doesn't feel like it's anything special. Like, we have a computer made of meat in our skull, and it's amazing what we're able to accomplish, and thanks to hundreds of millions of years of that evolution. When you look at computers, I don't see why we wouldn't have artificial intelligence that is the equivalent or vastly beyond what human beings are capable of. It's like, there's nothing special about our meat computers. They're just the ones that we ended up with. And there are probably dozens of different ways, hundreds, thousands, millions of ways that intelligence could arise in different configurations. Humans being one form, artificial intelligence being another form, some other life form on some other world being another form. And I think, like, we perceive the world from the perspective of being intelligent creatures. And we can't imagine something that is more intelligent than us, that isn't us. But that doesn't mean that it's not possible. And so I think that we're about to find out what it feels like to share planet Earth with something that is as intelligent or more intelligent than us. And I hope we can figure out how to remain friends. Joe Conrath, what is your preferred answer to the Fermi paradox? Someone's new to my channel. Guess it's time to... I'll give an answer, and then we'll begin a multiple episode argument. So let's do it. Joe Conrath, what is your preferred answer to the Fermi paradox? I think we're alone in the universe. I think we are the only intelligent civilization potentially capable of space flight in the universe. Not only that, but I actually think that we're the only life in the universe right here on planet Earth, that there's no other place in the entire observable universe that life has formed at all. That's my preferred answer. The alternative answer being the great filter, that all life, when it reaches a certain point, gets wiped out. It's just so horrible that I don't like that answer. So I'm going to go with we're alone, or we're first. That's okay too. We are the most advanced species in the universe so far. Blue pill or red pill? I forget which one is which. Which one makes you bigger and which one makes you smaller? Isn't that how that works? That's an Alice in Wonderland question, right? I love it. He can't be serious. Oh, that's funny. It's seriously the argument in the chat, right? Because like how many times have I expressed my my perspective and given all of my rationalizations? So I think it's funny. It's welcome new people to the channel. It's great to have you here. One side of the mushroom or the other side of the mushroom. Is that how it worked? Okay. Yeah, I'm trying to remember how to answer that. Andrew Pack, Fraser, are there promising theories to explain how the giant ancient galaxy ejected by JWST formed so soon after the Big Bang? Could it be evidence that the universe wraps around on itself? Did you see the interview that I did with one of the researchers who found those galaxies within the last, I think it was last week that we posted the interview? So we go into that and why. I mean, his opinion is that it's 99% that one of the underlying assumptions that astronomers make about the universe is wrong, or so it's a combination of all of them, but not that the cold dark matter lambda concept of the universe is what's wrong. Like, it's not overturn all of our established laws of physics about the universe wrong. It's merely we don't understand how the galaxies came together. We don't understand what role that black holes formed. We don't understand the role of dust. We don't understand errors in our measurement, and on and on and on. And they all add up to big galaxies early. But it wouldn't be evidence that the universe wraps around on itself. So astronomers have looked for that. They've looked for patterns in the cosmic microwave background radiation on one side of the sky, and then look to see if you can see the same thing on the other side of the sky and see that mirroring. But you should definitely check out that interview. All right. All right, so we've reached the end of the hour. So why don't I'll record all of the extra stuff, and then we will get on with overtime. So don't go anywhere. I'm going to do a bunch of administration work, but please don't leave. Don't leave. Don't leave me. All right. If you like my answers to your questions, as well as the other things that we do at Universe Today, why don't you consider joining our Patreon club? This allows us to keep a minimum of ads for everybody. Like, as you can see, there are no ads during the middle of this video. As a patron, you also get an ad-free experience on universetoday.com for life. Even if you unsubscribe, you'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: John Tolles, Nolan Dwyer, Norman Gluckman, Shiram G, Todor Nakev, Grald, Modsu, Lynn Raymond, Judith Arnold, and Alf Badencourt. Join the club at patreon.com/universetoday. All right, those are all the questions. Oh, yeah, I'm not going to read that out. All right. All right, those are all the questions that we had this week. Thank you, everyone who asked questions in the chat, everyone who showed up for the live show on Mondays, 5 p.m. Pacific time. Don't forget to vote, and we'll see you next week. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at university.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at university.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to David Giltonen, Modsu, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verbioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. And now I've got to do a intro. What's the biggest possible planet? How will we mine asteroid Psyche? Will we ever see the rest of the universe? All right. What is the biggest possible planet? How will we mine metal asteroids like Psyche? And will we ever see what's outside the observable universe? All this and more in this week's question show. Okay, let me stop my recordings. And then we will go into overtime. Someone asked how my ice cream was. It was terrible. It was awful, but we still ate it. It just kept freezing because I didn't have any way to keep it churned. And so I kept having to pull it out and stick it in the bowl and then let the bowl melt a bit and then put it in the blender and then blend it up. And yeah, it was awful. But I'm trying again. So this time around, I made another batch of ice cream just 2 hours ago, and I put them in ice, ice cube trays, and then I put them into the freezer. And so then I'm going to pull out the ice cubes and drop them into the blender and then blend them up, and hopefully that'll turn into ice cream. But I refuse to buy a machine that's only job is to make ice cream. But I may crack eventually. Yeah, terrible ice cream is still not bad. So I think I can kind of pull it out. And in fact, my wife likes melted ice cream, which is a lot easier to achieve than ice cream with that really good, freshly, scooped up texture. So melted ice cream is doable. Master of my domain level of membership. It baffles me that people support us at the $100 a month level. I'm still stunned that we have this level of support from the patrons. Actually, it's kind of amazing. We hit 1,500 patrons yesterday, and balancing that with the drop in advertising revenue. I don't know if you've seen, but the media landscape is cratering. I've heard that Vice News might go out of business. A lot of big media organizations are laying off tons and tons of people. And so I was looking through my ad rates, and our advertising is down 65%-ish from this time last year because of a drop in how much people are able to pay for advertising on websites. But that shortfall has been nicely balanced by the increased number of patrons, which is amazing. And for the longest time, it never felt possible to me. I look at, we'll never get to a number of patrons that we could be completely independent. But now I feel it. At 1,500, I think we would need to get to about 3,000. If we got to 3,000, then I think I could just cut all advertising and then just run the machine. There'd be no ads on the website. There'd be no ads. Well, I mean, we can't remove the ads from YouTube because YouTube won't let us. But still, there's no ads on our podcast. There's no ads in the newsletter. And then I would need like several thousand people to wake up one morning and go, I don't want space news from Universe Today anymore to cause any disruption whatsoever in our business. So it's kind of amazing. And I feel like maybe 2-3 years we'll get there, and then we're bulletproof. Like at that point, we are a truly, completely independent space reporting agency. So anyway, that's the plan. That's the goal. And I can't wait to go completely independent from like everything except for you. Classy Caribou, I would like to support, but I refuse to use Patreon. That's okay. Like, you don't have to. Like, the nice thing is that other people support, and the goal is to make this, we provide everything with a Creative Commons 4.0 license. You can take all of the content that you want and use it for any purpose whatsoever. Go ahead. Like, that's fine. Hold whatever stance you want about Patreon. It's cool. Do whatever you want. What's for dinner tonight? Probably chocolate cake. Because it was my wife's birthday a couple of days ago, and I made her chocolate cake, and we're still eating it. So that's probably what it's going to be. I suspect she's already eaten dinner. Tight around. I never watch ads. Well, I mean, of course, there are ways that you can consume content and not have to see any ads. Like I have a YouTube Pro account, so I don't see any ads on YouTube when I watch it. Obviously, you can install AdBlock Plus, and then you don't see any ads. But the problem is, obviously, that it doesn't contribute to the bottom line of the people who are creating the content. And so if everybody did that, then nobody would be able to create this content. And then it would all just be Chat GPT all the time, which kind of feels inevitable, but we'll still fight before that goes. What are those on your bookshelf? Let's see. I've got a 3D printed Falcon rocket that somebody sent me. I can't show you my eyes or else my camera will settle on them, which is really cool. Falcon Heavy. I've got a metal meteorite. Again, don't look at the camera. This is actually a present from my wife, which is pretty cool. I've got a recreation of the Pioneer plaque that somebody sent me. That's really cool. What have I got? This is cool. So I forget what this is called, but it's the moon, and it's pretty heavy, and there's like an app that goes along with it that you sort of like, it's augmented reality, and so you could look at the moon in augmented reality and then be able to see what the different craters are and stuff. But then I lost the app, and I don't really care, but I just like this, you can feel all the craters and mare and stuff. It's really neat. This was sent to me by Dustin Gibson from Oceanside Photo and Telescope. Got a commemorative plaque for reaching 500 episodes of Astronomy Cast, thanks to our good friends at the Weekly Space Hangout crew, including like Nancy Graziano, who is here right now. So thanks, Nancy. That was 500. We just hit 675 episodes now of Astronomy Cast. Man, what else have I got? I've got some chunks of the James Webb Space Telescope's sun shield. So this is actually what the sun shield is made out of. Well, it's got multiple layers of this, but each one of the layers, if you look, Is it picking up my eyes? Okay, good. Is like multiple layers. You've got this kind of mylar sheet, and then you've got this it's like a little netting, and then another mylar sheet, and then another little piece of netting, and so on. Multiple layers all sandwiched together, and it sort of feels kind of spongy. And so this is what protects that stops the heat from reaching JWST. Is it's got multiple layers of this sun shield, and so the heat comes in one side of it, has to get through all these different layers. So Pamela, my co-host on Astronomy Cast, she was at the Goddard Space Center, and they had a bunch of this just in a little bucket, like leftover parts from JWST. And so someone said, "Hey, do you want some of these?" And she's like, "Yeah." And then she gave me a bunch one time that we met at a conference. She was like, "I got a present for you. Here, check this out." And so she gave me a bunch of these chunks. My TRAPPIST glass. Yeah, I have a TRAPPIST glass kicking around somewhere. I've still got a lot of stuff packed away in storage, but I'll definitely try and find that TRAPPIST glass and get it set up. It's cool though. Like I get this stuff just kind of sent to me. Oh yeah. So let's see. So this is cool. So this is, so where we live on Vancouver Island, we're pretty close to Mount St. Helens. Like when Mount St. Helens went off in 1981, it sounded like this giant boom that we all heard. And I have family that are downflow from Mount St. Helens. And so they went and scooped up material from Mount St. Helens. And so mostly it's ash, but they also grabbed some chunks of material as well, pumice, and they float, which is really cool. So this is Mount St. Helens ash in a little uncooked honey jar, which is really cool. What have I got? I've got more meteorites. So, and I'm sure Nancy's got one. So, again, close my eyes. So, I've got a whole bunch of metal meteorites. These are, no, it's seeing me, isn't it? Of course it is. Okay, there. I've got a bunch of metal meteorites. So, these are from the Campos del Cielo meteorite impact in Argentina. And so they're easy to buy, actually. I picked up this trick from Phil Plait, the bad astronomer. This was his shtick. And actually, he gave me a meteorite when we first met. And so he said, "Oh, here's a metal meteorite." And you just feel like, "Oh my God, this is the most amazing thing. It's like a piece of space metal." And then I'm like, "Oh, how did you get this?" And he was like, "I just go on eBay and I buy them in bulk." And you can too. So you just go on eBay or Amazon and you can find metal meteorites. And hopefully they're legit. In some cases, I'm sure someone has some way to make fake meteorites, but apparently there's just like so many of them fell in Argentina, and they turn up all the time with metal detectors that you can get your hands on them. And so the one that I showed you earlier, the one that my wife got me, this one here, is, it's about a pound. And so you can buy them, with certificates if you're like really serious. But for like a couple of $100, you can buy a metal meteorite, and it is the most wonderful thing that you can own. Like, it's so great to have this chunk of melted blobby space metal that impacted the Earth at some point in the ancient past. So I highly recommend it. Go on Amazon. If you want like a dependable supplier, go to like Aerolite meteorites. They're a pretty good, they're the people who did Meteorite Men, so you can trust them. So yeah. What is the red Optimus tentacle thing? So this is a crab. It's a crab puppet. It's actually a thing from my mother. So my mother passed away about 10 years ago, and I've got like a couple of things from her. And so when I grew up on this small island, one of the women on the island sewed these really cool puppets, and my mom bought one, this one. And so when she passed away, I got a couple of things of like in memoriam for her that I sort of keep behind me. There's this, and then there's also, I don't know if you can see it. I'll grab these two. So the other thing that she gave me was the thing that I kept. So is a urn. It's like a little silver urn. I can't. Come on, camera. That comes from China. So my family, when I grew up, or about I guess about 80 years before I was born, my great grandfather lived in Shanghai and was an engineer working in helping build the city. And so he collected a whole bunch of artifacts from Shanghai, like embroidered things. And so one of the things he brought back was the silver tea set. And so this is designed for holding tea. And the thing that's always kind of cool is you count the number of toes on the dragon. And so like the five-toed dragons are only for the royalty. I think the four-toed were for like rich people or something like that. And so it's really cool. And then the other thing is a mini museum. So my wife got this for me for my birthday one year. And so it's little pieces of things that are really cool. Like a piece of a Jurassic tree, space gems, fossils, piece of like a supercomputer, Cray supercomputer. I don't know if you could even read the things in it. So, but like one of the cool things about being a YouTuber is people send you stuff. So, whoa. I don't even know what you're saying, God Jesus. God Jesus, to understand, sorry to realize you're in reality is lots of work, but if schools start to show kids how to use meditation, not complicate meditation, but deep breathing, one taught at a time, able to stop at start, very scary, you believe you die. So are you saying like meditation makes you scared? So would you let us pick a tattoo for your forehead? No. Oh my God. All right, I think we've reached the end of our show. I guess we did get more questions. You just got like a bunch. Yeah, there's some Parsec Awards back there from back when they had the Parsec Awards. That's what those are there. Our 4 Parsec Awards. Until we just stopped entering because we just kept winning them all. Is God used a bad AI? Maybe. That's funny. All right. Well, thank you, everyone, for hanging out again for another question show. Thank you to all the moderators. Special thanks to Nancy Graziano for leading the team. Thank you for Chad and Anton in advance for what I'm about to send your way for you to just start editing. Thanks for everyone who asked questions, both in the comments as well as here live. So much fun. I really enjoy this. Hey, Fraser, love the show. Trying to listen to more interviews. So today I interviewed the director of the United Arab Emirates Space Agency, which was pretty cool. So listen for that in a couple of days. All right. Thanks, everyone. I'm going to go eat now, figure out whether that ice cream was a failure or not. And we'll see all of you next week. Thanks, everyone. Where's the button? There it is.